to solve equations that have exponents, x in the exponents, or that have logarithms. Okay? That's the big thing today. The 4 strategies listed first on worksheet 9B. Okay, there's 4 strategies to look at here. This first one we actually don't see very often, so I'm going to kind of go quickly here. It says, if a problem has a single power of x, isolate the power and use a reciprocal power to solve. This, we've been doing this all along, okay? If it said 2x squared minus 6 equals 9, we'd add a 6 over here and we'd divide by 2 and then we'd square root both sides. Does that sound about right? Because there's no x in here, so we don't have to factor it. We'd just isolate the x squared and solve. This is the same thing, but now we have some funkiness up in the exponent, so we're going to use a reciprocal at the end. But again, we're going to use our Algebra 1 brain here and divide by 15 first. So we'd end up with an x to the 2/3 equals, that comes out 4, I think. Now, before we do this reciprocal power thing, can you remind me what an x to the 2/3 actually means? It's a cubed root of an x squared, or you can cube root and then square, okay? So we could undo this in 2 steps, but we can also undo it. One more review here. What would this mean? Everybody good that you multiply to get 10 here? Well, we're going to use that idea. We're going to multiply up in the exponent here. We're going to do to the 3/2 on both sides. Okay. It basically means we're square rooting both sides and cubing both sides at the same time. Because we'd multiply these exponents and we'd get 6/6. Does everybody understand how that works? We get a 6/6 here, so an x to the 6/6 is just x. And then over here, you can definitely do this on your calculator, but it means 4, the 1/2 means you're square rooting, and the 3 means you're cubing. Now you can do it in either order. The square root of 4 is 2, 2 to the 3rd power, anybody? 8. Or you could cube it first. 4 cubed is 64, and the cube root of the square root, I'm sorry, of 64 would be 8. So it doesn't matter which order we did it in, and I'm not taking your calculator away, so you're good. All right, so how are we going to start the next one? Divide by 3, we get x to the 1.2 equals 19, I believe. Now, very rarely in math do I allow you to put a decimal into a fraction. Like, leave it that way. But I'm really okay here if you just say to undo a 1.2 power, I'm going to do the 1/1.2 to both sides. It isn't going to be pretty no matter what we do. 1.2, if you did a math enter is 6/5, so we're really doing the 5/6 power, but it doesn't matter. We're just going to go here and we're going to type 19 to the, was it 1/1.2? Yeah. Okay. Now, this particular lesson, you will be a lot closer to right answers if you don't round too soon and if you don't round to too few places. I don't know what Delta Math does. I think they ask for like hundredths on some questions, thousandths on others. So you're just going to have to go with what the question says. But I try not to round until I have to. And I'm going to go with 3 places today. So I'm going to put down 11.361. Is that right? Did I? 631. Thank you. I'm like, I don't think that was right after I said it. Now, could you guys go back to the beginning real quick and type for me? Do 3 times 11.631 to the 1.2 power and see how close you get to 57. It's like 56 point. I just type in this. But if you only put in like 11.6, try that. Do 3 times 11.6 to the 1.2. Then it's a lot further away from being exactly 57, yes? Yeah. So that's why I try to carry more decimals, okay? Logarithms and exponents make a big difference with variable, the number of places. It's not a big deal. On my quiz, you know better. How far is not super picky, right? As long as you got 11.6, I'm going to be fine. But be careful. Delta math is picky. All right, next section. All of these problems have x where? Nope. In the exponent. Okay, this is huge. Most basic concept of exponential equations. If a problem has an exponent where the variable is in the exponent, exponential expression, anytime the variable is in the exponent, you want to isolate that quantity, and then you're going to have to take the log of both sides. Okay? Anytime the variable is in the exponent, the unknown that we're trying to solve for is up in the exponent, you're going to have to take the log of both sides. Do I need to say that a third time? When do you take the log of both sides? Yes, if the x is in the exponent or whatever we're trying to solve for. Okay, next thing. Can I simplify 50 times 3 is 150? No. Somebody's going to do that on the quiz, and then everything from there on is going to be wrong. This, only the 3 is to the 2x, so we have to isolate that 3 to the 2x, so we're going to divide that 50 off each side, which I believe makes this one 25. Okay. Then it says we're going to take, we decided, we just said it 3 times in a row, that we're going to take the log of both sides. You can do the log, log base 10 of both sides, the common log. You can do the natural log of both sides. We could rewrite this as a log base 3, but does every calculator out there have a log base button? No. So we're going to just take either the log, common log, or the natural log, and it doesn't matter which. I'll do log on this one, so I'm going to write log of this side, and then I'm going to try to slide this over. No, I'm not. And I'm going to write over here the log of this side. You might just probably should have rewritten it, but okay. Now, what property of logs do we need to do next? Yep, we need to take that exponent, and where does an exponent belong? Out in the front as a multiplication. So we have now 2x times the log of 3 equals the log of 25. All right, all we have left to solve for x is to do some division, right? I usually do this in 2 steps because it's a little less complicated on the calculator and a little easier not to make a mistake. You can divide the 2 at the same time, but you need parentheses then in the denominator, and students tend to forget. So we're going to do the log of 25. Close your parentheses, divided by the log of, was it 2 or 3? I already forgot. 3? Okay, I do want to show you that I could have used ln. And as long as I did ln of both, it will be the same answer. Now, can I just get rid of those and do 25 divided by 3? No. Okay, the log is a function. Okay, it's like you're squaring the top and bottom or square rooting the top and the bottom. You're taking the log of the top and the bottom here. You cannot just simply forget that step. All right, but this was not the answer. What did we still have to do? This number I needed to still do what? Wasn't it just divide by 2? So 1.465. Now, if you rounded earlier in the problem, could you be off by a tiny bit at the end? Yes, for sure. Okay. And that's not going to bother me. All right. So talk me through this next one real fast. Because this is the same problem. It's even easier. Divide by 6.6. Now, this is where Hofbauer laziness comes in. I don't like to pick my calculator up till I have to. So I would write this as 0.5 to the x equals, and I just leave it 0.8 over 6.6, because I really don't know if that's going to come out nice. Actually, I do, because someone told me it does. But I'm just going to leave it, because I can type it in a minute. Now what do I have to do? Take the log of both sides, and as soon as I do that, that x is going to move out front. So I'm going to write x times the log of 0.5 equals the log of 0.8 over 6.6. So what's the last step I have to do? Divide by that messy log of 0.5. So I won't remember those numbers. The log of 0.8 divided by 6.6. And then divided by another log of 0.5. I remembered. Oops, not 0.55 though. Everybody getting 3.044? Anybody have a question? Please tell me if it's not coming up that way on your calculator, okay? I was trying to help someone earlier and they were typing the X into their calculator. Can you ever type the X into the home screen? Does anybody know what will come up if you type the X? If everybody in this room just typed the X button and then enter. I got 10. What did you get? 0?
Yeah, so whatever it's 15.
Yeah, it's really whatever you traced last out. It has to do with the graphing. So anyway, we're going to keep going. What's different about C?
That's an E.
It has an E. Ooh, I heard natural log. Does anybody think we should use ln this time?
Yes.
I think that would be a really good idea. Let's see. Put this on a new page here. If I divide by 150 first, normally I'd leave it, but that's kind of a big number. Does it come out nice? 600? Okay. Since it came out nice, I'll go ahead and not carry all that writing. We're going to do ln this time, and it's a real important property I've tried to drill into your head. 0.5x times the ln of E equals ln of 600. It is a 0.5. Okay. Do you remember what the important property I tried to remind you? The natural log of E is just what? 1. So this is times 1, which is just 0.5x, right? So then the last step would just be to divide by 0.5. Not the log of 0.5, just 0.5. Someone just want to tell me what that is?
12.794.
Are we going to trust Alexa? Or Google? All right. Number 3. This is an important property that you're supposed to know that didn't go that well on the quiz yesterday. So I'm going to write this down and then I'm going to erase it here. But do you remember this idea? The base to the power is the number. The log base b of some number is the power. Some of you couldn't do that on the quiz yesterday. Yet when it said this, it said log base 4 of 64. You were all over writing this down for me. Isn't that the same thing? I just wanted to cry when some of you could do this over and over, but then you couldn't switch them when it was all letters. Anyway, I think you'll get it. You just need to look it over one more time. I'm not trying to be hypercritical. I just want you to realize that you really do already know how to do this. Okay. What is the base on this question? When there is a single log within a problem, this is very different than when there's multiple logs. When there's a single log, you want to isolate it and then rewrite it as an exponent sentence, like we just practiced. So this literally means what to what power equals what? What's the base when it's log? So this literally means 10. The answer to the log is the power of 3. So 10 to the third equals 2x plus 20. That's it. Now it's an algebra 1 problem. This is 1,000. We need to subtract 20. I think that's 980. And then we need to divide by 2, which I believe is 490. I'm going to do a commercial break here. Some teachers teach it this way. I think Mr. Hardy is one of them. I'm not a huge fan because it feels like magic to me, but it's okay if this is the way you want to show this. This is a base 10, right? So what they do is they say, I'm going to exponentiate both sides.
Yeah, I remember this.
And then this cancels each other out. And you have 2x plus 20 equals 10 to the third, which is 1,000, okay? It's the same thing that I did, but I tried to make sense of it that we're rewriting from an exponent. This feels like magic to me. And it's okay to do it that way. But it's really the same thing I'm doing. Does everybody see that? Okay. I don't want you to think I'm trying to make it harder. I'm just trying to make you understand why it works. Okay. What's wrong with this one, though? Before we do anything, our Algebra 1 brain needs to kick in and say, I got to divide that 3 off the front. So I have the natural log of x plus 2 equals 2. What is the base on this problem? E. So this means literally e to what power equals what? The answer to an exponent is the power, so that's the 2. And the question we were asking of is x plus 2 here. Now, this is one that Delta Math might ask for an exact answer. Can anybody tell me what you would type in if this asked for an exact answer? You would say e squared minus 2 equals x. It's like, do you remember in geometry the teacher would say you have to leave it in terms of pi to get an exact answer, like you found the area and it was 16 pi and you just left 16 pi? E squared is an ugly decimal, so they might ask for an exact answer in terms of e. But you can also, for my sake, type that in. I will tell you that I like to use, did I turn my calculator off? How did I manage that? E squared, I like to use the ln button to get e. If you do second ln, then it brings up e with a little box. And then you can just type the squared and then the minus 2. Wasn't it minus 2 or plus 2? Minus 5.389, anybody? All right, then we get to talk about when we have multiple logs. This is why we had to know 3.3, okay? Condensing and expanding logs. We did a little bit of it already when we moved the exponent out front, but that's a pretty easy one to remember. Beyond that, when you have 2 logs, these are 2 very different questions, by the way. This one has logs only on one side, and this one, everything is not a log, right? This one has logs everywhere, but there's not really, you have to condense them first and then decide where you go from there. 2 logs that are added become 1 log that is what? Multiplied. So we have a 2x times an x. It's just going to become a 2x squared, but I'm not writing it that way because I want your notes to be able to know where it came from. Do you remember that adding means multiplying, okay? Now, it's 1 log, so which kind is this of the 3 strategies above this?
Number 3.
Number 3, we just need to rewrite this as what? What's the base?
10. So
10. The exponent is the answer of the log. And I'm going to write 2x squared this time. Is everybody okay that? Okay, so finish that up. This is 1,000. We're going to divide. So we get 500. I'm just skipping because I don't have a lot of room. But did everybody get to 500 one way or the other? And then we need to do what? Okay, and when we square root an x squared, we should remember plus or minus 500. If I wanted an exact answer, would be the square root of 100 times 5. So you could say plus or minus 10 square roots of 5. You could also give me a decimal. But let's talk about this for a minute. Remember everybody's favorite math cuss word? Extraneous? I'm going to make it a cuss word. Okay. If you put a negative number back in here, are we allowed to take the log of a negative number? No. But I must caution you that you can't always throw a negative away. If it said this, can I put a negative number in there and take it to the 4th power and it'll become positive, etc.? So just because you get a negative at the end doesn't mean you have to throw it away. You might have to check, okay? Don't always throw your negatives away. And sometimes you have to throw positives away because of what it says. This one, you have to throw it away. So it's 10 square roots of 5 is the only answer that works. Or approximately, anybody have a decimal for me? Square root of 500 is 22.36. Thank you. All right.
Hey,
What's wrong?
I tried exponentiating it and it didn't work out.
Which one?
The one that we did. I tried exponentiating it, like Mr. Hardy.
Okay. But you have to exponentiate it after you combine it.
Yeah.
So you would put a 10 here and a 10 here, and you'd get 10 to the 3rd equals 2x squared.
Yeah, no, I moved the square to the other side of the log, from the log.
You can't. Wait a minute. Because if you write, I understand what you're thinking.
Yeah.
I talk about this. Why can't I move this 2 to the front? This squared is only applying to the x. It's not to the 2. If you were going to move it to the front, you would have to separate it first. So you'd have log base 10 of 2 plus 2 log base 10 of x equals, and then you're back to having 2 logs, okay? Thank you, though, for asking, because that is a great question. I knew we came up with that earlier today, and I forgot why it came around. Okay. This is the temptation, guys. I get students who do this. Oh, I'm just going to get rid of these. Does that seem okay? Probably not, huh? Okay. What we have to do is combine into a single log. Any ideas how this is going to combine into a single log over here? Where's the 2 going to go? Yeah, x squared. And then the minus is going to become, so we have an x squared over 3. Now, there's an amazing property called the 1-to-1 property. It says if you have, for example, let's say 6 to the x plus 5 equals 6 to the 11, x plus 5 has to equal 11. The same is true for logs. If you have the log of 2x equals the log of 4, 2x has to equal 4, right? X would be 2, yes. So guess what we can do? We can get rid of the log on each side because we have a single log equal to a single log. So this quantity has to equal this quantity. You are not dividing both sides by log, okay? You are undoing it. I guess you could put an e to the power of, yes, to get rid of it. You could exponentiate each side. But the one-to-one property says they just have to be equal. Okay, then finish up how to get rid of divide 3. So we'd have 36, and then we'd square root and get plus or minus 6. Now, we got to go back to the very beginning. It just said log of x, so can it be a negative? No.
Is there ever a time where both can work?
Yes, yes, for sure. I could make both work simply by starting the problem out as the log of x squared minus the log of 3 equals the log of 12. Because as soon as you put a negative in and square it, it becomes positive. But this one started out with the 2 out front, so that makes it impossible. Yes, Cade. Yep. Yes, yes, you could definitely have rearranged this problem. Should solve the same. Okay. What happened to my questions on these pages? Wow, that's really weird. Everything is gone from here on out? Okay, I don't know what's happening. There's 4 problems. You have 2 minutes. Do them. I've never had stuff disappear off my slides before. It's like it's invisible. I copied it over and it's...
Oh, recording too.
Yeah. All right. You guys are probably way ahead of me, so I'm just going to write down some steps and see if we got the same answer. Please let me know if I need to go back and explain something. I'm just being lazy and not using my calculator till the end. Who's going to tell me what they got on that one?
The first one I got
150 divided by 60, close parenthesis, divided by 0.2, 4.581?
Yep.
No?
Yeah. I messed up.
150 divided by 60 is 2.5. So did some of you have ln of 2.5 divided by 0.2? You didn't get this? Divided by 0.2? 0.2? This is 2.5. Riley, no?
I got that.
Oh, forgot to move this to the front. Okay. All right, divide by 4, x to the 0.4 equals 70 over 4. Then we would do to the reciprocal power, 1 over 0.4. 70 divided by 4 to the 1 over 0.4. I got 1281 something. Yes? Anybody stuck? I really thought you guys were doing good. Did you not follow the examples, or are you okay? Okay, this one plus means what?
Okay.
So this is an x times a 3 or a 3x, and then this side has a log, so we can just say, yes, so we get 16. Did you get that one right?
Yeah.
We divide by 3 here, we get log of x over 2 equals 2. What power is this one? This is a base 10, so 10 squared equals x over 2. That's 100, and how do we get rid of a divide 2? So 2 times 10 squared would be 200. Did you get that? Okay. There's one more kind we have not done very many of, and that is when they can be written as a common base and solved exactly. This is on the next page. It says if you can rewrite equations to use a common base, and then use the properties to simplify, and once you have the same base, you can set the exponents equal, okay? This would say then x equals y. Is that filled in on yours or not? Everybody find where we are? Okay, yep, remember I had to flip slides, so these are already done. Da-da-da-da-da-da. If I just clear ink. Okay, so the very first one up here that I can't read says we have two things that have the same base, so therefore the exponents must be equal, and I'm not going to solve because I think you could all solve that, yes? Okay, we're going to keep going. The next one has two things multiplied. Do you remember what you do when you multiply two things? You keep the base of x and you do what to the exponents? Add. So we're going to keep the base of 8, but we're going to add these exponents together. And I'm going to write it all out so you can combine the like terms in a minute. Same thing on the right side. If we keep the base and add the exponents, got a hot mess, but what can we say right now? Can we get rid of those 8s? And just say those exponents must be equal? I combined my like terms now. Now, I'm just going to, if you don't want to even bother to copy this down, you don't have to. It would solve k minus 5, k plus 4. So you would get 5 or negative 4. Can you have negatives in the exponent?
Yeah.
Yes. So you keep both of these solutions. I know I went really fast, but could you have done that part? All right. Sometimes we have to totally rewrite something with a common base. This is actually the more common thing that happens because these are not written as the same base. Do you remember yesterday what a 1/64 is a power of 4 as well?
Yeah.
4 to the third is 64. What puts it in the denominator? So this is a 4 to the third with a negative exponent. And then this one is a 4 to the a squared minus 4. So we'd have negative 3 equals a squared minus 4. We'd add 4 and solve. I'm not going to finish. Is everybody okay with that? Let's try set this one up. What is this power of 12? That's 12 to the negative 1. But what am I going to do with that negative 1 and that 4x plus 3? Does anybody know? Yeah, I am going to distribute it, so I'm just going to leave it like that right now. And then I have a 12x squared equals a 12 to the 2x plus 13. This doesn't look like a 12. Okay, what do you do when it's multiplied to the exponents? Add. So I'm going to distribute right now negative 4x minus 3, and then I'm going to add that x squared. Okay, so then you'd have to set those messy exponents equal, and you'd have to get it equal to 0 and factor and garbage like that, okay? What I really want to do to finish today is talk about these two questions. Anybody find this, what worksheet this is? It's called Log Equations Type 2.
11A.
11A? Nope, that's type 1. 11B?
11B.
Okay, I just want to set these two up because this is the kind that students struggle with the most, I feel like. Maybe not. Maybe it's the... But what's happening here? How do I rewrite this one to start it? 2 to the 7th equals 3x minus 4. That's it. You don't have a log anymore to worry about. What about this guy?
The
E to the
9.
9th equals 2a. So if you wanted an exact answer, it would be e to the 9th over 2. If a delta math question asked you that, okay. I'm going to go back one, and you don't have to necessarily, but look at this one, guys. When you have log base 3 of 7x minus 1 equals log base 3 of 5x plus 17, what do you think you get to do? Yeah, 7x minus 1 equals 5x plus 17. Okay? When you have exactly one log equal to one log, you're good. Golden. Okay. I will do more practice tomorrow. That is not the assignment. The assignment is, do I have the right slide on this one? Man, I have a hot mess going right now. Didn't they just show up when I went back to this? They're there. Remember a minute ago those weren't there? This is the one I was just doing and they weren't there. Oh my gosh, it's magic. Okay. This is the assignment. It's just delta math tonight, okay? I want you to get some feedback so that you know you're doing them right by doing the delta math. Remember, you can always look at an example in delta math if it's not going well.